Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we are now in chapter 6. As you see the screen here now, with the topic of data description. So for whole of this topic, we are going to look into we call 6.1 Introduction to Data, 6.2 Measures of Location and Measures of Dispersion. So okay, so for lecture 1 of 3, the first part of this topic, 6.1 and 6.2, Introduction to Data and Measures of Location. So when we talk about data, we might have in our mind that we are going to talk about mode, median, and mean. Okay, so when given to us any data of a recall, marks of a students in the class, or might be the numbers of people in any residence, or might be numbers of books in the shops, among the shops there. Okay, so we might mostly we're going to look into this part here: mode, median, and mean. Okay, so here we're going to look at identify the discrete and continuous data, ungroup and ungroup, construct and interpret step and leaf diagrams, and interpret the mode, median, and mean. And also quartiles, percentiles. Okay, so as you see here now, this is all the things that we're going to discuss for the first part of our lecture for topic 6. Okay, so statistics is a discipline that concerns the collection, organization, displaying, analysis, interpretation, and presentation of raw data. So from here, from this raw data of smartphones owned per family example, so we can elaborate all this data into this pie chart, or this one here, a graph. Okay, we call pie chart and also a graph. A set of data is collection of observation, measurements, or information obtained. So, which I think that all this you read by yourself, or you may refer to the lecture notes. So, data can be classified into discrete or continuous. What is discrete and continuous here? Okay, so discrete data can only take exact and countable values. For example, the number of students in the class that are impossible for us to describe. There are 7.35 persons or students in the class. 7.35 students. So how do I describe the 0.35? Even though might be the students have no legs or no hands. For example, we don't describe that person as a 0.35 person. You still consider that as a 1 person. Okay, so discrete data is that numbers that of the people can only take exact and countable values. For continuous, you can take any value over a certain interval. Okay, the weight of students in the class and time taken to complete an examination. So then the weight of students might be 70.35 kilogram, 60.25 kilogram, and you name it, as long as it's an interval here. So just like interval, if we look at this one, between 2 and 3, there are values of, let's say, 2.35 or 2.89. Okay. Any measures, characteristic, or attribute that differs to the different element. For example, if weight of 30 subjects were measured, then weight would be a variable. Okay. Like classified as quantitative or qualitative. Okay, so the quantitative variable, variable being studied in numeric. Okay, so as you see here now is time and weight. So the variable being studied is non-numeric. Categorical variables, for example, gender, height, and color. So we cannot measure the gender. Gender can be only man or woman, male or female, boy or girl. Okay, so we cannot, measure. We call the female. We call the male of that person is 3.5 male. No. Okay, we cannot measure it. It's an eye color or might be something like that. We call that related with all this. So we can only categorical variables here. So for examples, the number of books. Okay, so books we can count it one by one. So then the number of books sold by a stationery shop, then it is a discrete. Time taken to travel from Kuala Terengganu to Batu Pahat. If time taken of hours can be measured exactly one by one, for example, 2 hours, 3 hours, 4 hours, 5 hours only, then it might be, we call, a discrete. But then we know it's at 2 hours and 35 minutes, 3 hours and 14 minutes, and 35 seconds, 5 hours, 38 minutes and 14 seconds. So this one for time, it is continuous. Number of A's or for UPS in this semester is a discrete. Okay, the number of students is getting A. The weight of student in practicum, continuous. Okay. So then we classify for the first one here, we call it as an ungrouped data, which is a raw data not in the term of interval and can be in the form of frequency distribution that have been arranged in order. For examples, here 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 students sitting for a test. Okay, test or mathematics test for topic 1. And then I check their work and these all the marks out of 10. So there are 9 persons getting 3 marks, 5, 6, 2, 5, 2, 4, 6, 5. Okay, so it's not in arrangement, we call it an interval. It's a raw data here, so we call it as an ungrouped data. Okay, so and then we put them in a table with the topic of number of books. Okay, not this one here, nah? And then frequency, meaning that here we call the number of books that being borrowed by the students in the library is 0. We call no student. We call students. 3 of students did not borrow any books at all. 7 of them borrowed 1. 4 of the students borrowed 2 books, and 2 of them borrowed 3 books. Okay. And then for group data can be grouped into class interval. Okay, so this is the key for this explanation here. The keyword is class interval before the frequency distribution is constructed. Okay, so the table constructed is called frequency distribution table. For example, here. Okay, so the numbers of students who height in between 150 to 155 centimeter, there are 2 of them. So and then the height 155 up to 160 centimeter. There are 8 of them, and 6 and 5. Okay. Okay, when we given to us any raw data, we can also arrange them or describe them in the diagram, in the term of what we call a stem and leaf diagram. Okay. So for example here, the key is 14. Okay, 14 with 2 means 142. Okay, so okay, if I imagine this, okay, we call the raw data for this stem and leaf. We call this data have been arranged in the stem and leaf diagram. If I imagine it, the raw data is 136, 139, 139, 136, 39, 39. Okay, 142. 143, 143. So continuing until the last term here, which is 162, 162, and finally end up with 164. So this raw data, when we call arranged in the stem and leaf diagram, then this is the result. And the key is the stem with a 14 and 2 represent 142. Okay. So then the shape of distribution, a perfectly symmetrical curve, skewed to the right or positively skewed. Yeah. So positively skewed to the right, then this is it, the tail, okay, according to the picture here. And most of the data are on the left side. Okay, for this one here, it is balanced. The middle of the data, we call the data here. So it balanced on the left and right are equal, so a perfectly symmetrical curve. So then here now for this data, most of the data is on the right side of the graph, and the tail, small numbers of data on the left side, and most of them on the right side. Okay, example. So look at this one here now. Okay, it looks like this. 0 and 4. The raw data here is 4, 1 and 8, 18, 1 and 9, 19, 2, 3, 23, 2, 4, 24, until the last year is 60, okay, 62, 63, 65, and finally it ends up with 67. So the raw data, then we arrange from the smallest to the biggest numbers, and then we divide it into a stem and a leaf stem. So you can see here now, let's say this is the middle of the graph. So most of the data are on the right side and a few only on the left side. So distribution of show that most data are clustered at the right here. The left tail extends further from the data center than the right tail. Therefore, the distribution is skewed to the left or negatively skewed. Okay, so these are all the we call instruction on how to construct a stem and leaf diagram. So you can read by yourself, and we look into the example. First one here. Okay, so these all the raw data that I pick from the we call recent math tests are given below. The marks for the math test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 students and these all their marks. So it not arrange from the lowest to the highest. Okay, it's raw data here now. So let's recall the raw data from the question just now. It is 73, 42, 67, 78, 99, 84, 91, 82, 86, and 94. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 students. Okay, now to arrange them, let's arrange the numbers of data here from the lowest to the highest. Okay, tell me. This is the first one, right? 42. Okay. 67. 73. 78. Okay. 82. What else? 84. 86. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 91. 94 and 99. Okay. So then, if we divide this, okay, sketch a line, draw the line here. We name this as a stem and leaves. Okay. So take the first numbers here, which is 4. We got 6, 7, 8, and 9. Okay. So we only have one numbers begin with the 4 here, 42, 67, and 73. 73, 78. 80, 82, 84, 86. 82, 84, 86, 91, 94, 99, 91, 94, 99. So write down the key here. So 9 plus, let's recall, 9 here means 91 marks. So then the highest, okay, this is the solution of question A. Question B, let's read the question again. What is the highest and lowest marks? So then the highest marks and the lowest marks, the highest is 99. Okay, as you see here, 99. The last date final here, 99, and the lowest is 40. That's it. So, given the heights of 20 peoples are as follows here, the height of 20 peoples, construct a stem and leaf diagram and state the shortest and the tallest height. Okay. Okay. Now, let's say from this raw data, and then let's copy all this data again on the next page of this slides, and from the lowest to the highest. Okay, so then the first is 136, 139, 139. Okay, you list down all until the last final one here is 162 and 164. Okay, so sketch the line. Okay, so now 136. So we begin with 13, 14, 15, and 16. So list down here now 136, 139, and 139, 142, 143, 143, another 143, 143, 1, 2, 3, 4, 1, 2, 3, 4, and then 134, 37, 38, 138, and 139. So 151, 53, 54, 56, 57, and 162, 164. So the key here, 14/4 means 144 centimeter. So then we list down the highest, we call height, and the lowest. But the lowest here is 136 and the highest 164. The highest, the lowest, or tallest, or the shortest. Okay, so let's say if I put this one here as the tallest according to the question, and this one is the shortest. So the distribution here is positively skewed because according to this one here, if we divide it into two parts, most of the data are on the left side, okay, or left side of the data of the graph of leaf here, and there are less the data on the right side. So this is the tail, so it is skewed, positively skewed, or skewed to the right, or positively skewed. Okay. So we look into the first part of what we call introduction or discussion of what we call mode, median, mean, decile, percentiles, and decile and percentiles. So we are talking about mean. We're going to look into we call the definition of mode, definition of median, percentile, and quartile. Okay, quartile from the root word of quarter. Quarter. So let's say this is what we call a stick, and in the middle of the sticks it is half, and the middle between here and here another half, and between this line half, and here is also another half. So this is 1/4, 3/4, 1/2, or it is 2/4. Okay, so this is quarter, 2/4, 3/4, and 1. Percentile from the root of percentage means that over 100. Okay, so let's take a look at the next measures of location, ungrouped data. So mean is equal to sum of all observation divided by number of observation. And we can describe, or write in this one as the summation of all x divided by the number of data, represented by, we call these symbols here. Okay, and these two. Example 1, find the mean of data. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the number of data equal to 20. Okay, so now mean equal to summation of all x divided by the number of data, which is 20. So we list down 1 plus 4 plus 2 plus 0 until the last one here, plus with 1 plus with 2 and divide by 20. Summation of all this divide by 20. Okay, in examination you can't write this part here. Okay, so you may use your calculator, but then you need to list down all this. Okay, you are not allowed to do this. You call the simplified as this one here. You will need to list down all the numbers here, summation divided by 20. So this one here give you 41 divided by 20 equal to 2.05. The mean average, okay, I think that I have found that the similar words, similar meaning to the, we call the mean, which is average. Okay. Mode is a set of data, the value that occurs most frequently. May not be unique, okay, might be more than one, or there may be no mode at all. Okay, find the mode following set of data. Okay, so the numbers that occurs most, 3. Okay, 3 appear 2 times. 4, no, 5. 5 appears 3 times. So then, which numbers appears most? Appears we call the highest appearance here. It is 5, which is 1, 2, 3. 3 appears twice only. Okay, so then the mode equal to 5. Okay, there are 5 numbers here, and as you see for question B, there's none of these numbers appears more than once. 2 appears 1 time, 3 1 time, 5, 8, 10. So there's no mode. Okay, there's no mode here. And then 0.2 appears once, 0.4 1, 2, 3. 0.5 appears once, and 2 here. 0.7 1, 2, 3. So the mode is 0.4 and 0.7. Okay, so then for question B, there is no mode. Then here, the mode equal to 5, mode is 0.4 and 0.7. Median is the middle value of a set of data that is arranged in order of magnitude. Okay, for example, consider this following set of numbers here, 1, 2, 3, 4, 5, 6. So we arrange from the lowest to the highest, from the, we call the smallest to the biggest number here, 2, 5, 7, 9, 10, and 16. So the median class, if we divide it into 2 parts here, as you can see, there are 3 numbers to the left and 3 numbers on the right side of this middle line. Okay, so then the median is addition of these two, summation of these two, 7 plus 9 divided by 2, which is equal to 8. Quartiles, let's divide a set of data which are arranged in ascending in order into 4 equal parts. So to find the quartile, if you like to find the first quartile, or might be second quartile, third quartile. Okay, QK, K, which is either 1, 2, or 3. So then R equal to K or divided by 4 times N, where K is a quartile of the quartile and the number of observation. Okay, it's also recalled. You may read it here by yourself. We're going to look into the examples. Okay, Q2 is also called median. Median is the middle numbers of the data. Just like I recall, share with all of you just now. Okay, the half of this equal to half. Half from this half, another half here, and also another half here. So this is quarter, 1 over 4, 3 quarter, 3 over 4, and second quarter, 1 over 2, or 2 over 4. Interquartile range, third quartile minus first quartile. And percentile, divide a set of data which are arranged in ascending order into 100 equal parts. Okay, so number of percentile, K, might be P40, P55, or P50. Okay, or P55 is all up to you then. Okay, so then P25 is also first quartile, P50 second quartile, and P75 is third quartile. Example 3. Okay, so let's count up the numbers of data here. 1, 1, 2, 3, 4, 5, 6, 7. So number of data for n equal to 7. Okay, so now arrange in what we call ascending order. So we begin with 17. Arrange in ascending order. First with 17. Okay. And then 20. Next is 21. Then 24. 28. 32 and 36. Okay. So now from this we call arrangement here, 1, 2, 3, 4, 5, 6, 7. If I choose this number of 24, okay. So you can see here now there are 3 set numbers of data here on the left side. 1, 2, 3. And also another 3 set of data on the right side of this middle 24. 1, 2, 3. So it means that here the median equal to 24. Okay, from this picture. You might also use this one, which is 7 over 2, 7 divided by 2. Number of data is 7. 1, 2, 3, 4, 5, 6, 7 divided by 2 equal to 3.5. So we round up the numbers here. It is X4. Observation number 4. 1, 2, 3, 4. So then the median equal to Q2 second quartile equal to 24. Okay, it's either use this calculation or you can just simply look from the pictures. It's all up to you then. But then because every single single step is a marks, so I do strongly suggest to all of you to write down here like this. And then first set the median and the first quartile. First quartile, so then 7 multiplied with 1/4. 7, the numbers of data multiplied with the first quartile 1/4, which is equal to 7.4. Okay, 7.4 or 1.75. So we round up to round up the 1.75 into which is equal to 2. So the second observation here, this is x1, x2, x3, x4, okay, x4 here, observation number 5, observation number 6, and then the 7th observation here. So then Q1 equal to this 20. So find the third quartile and 14th percentile for the following sets of data. Okay, so for this one, again, we are going to arrange this data in ascending order, which is from the smallest numbers, which is 2.7, okay, 1 by 1, then we get 3.5, 4.3, 5.4. Okay, if I recall, imagine that if I cut the numbers 1 by 1, okay, 2.7, 3.5, 4.3, 5.4, then 6.2, then 7.6, 8.6, and 9.9. Okay, so the third quartile, so the number of data here, n equal to 1, 2, 3, 4, 5, 6, 7, 8. So the third quartile is 3/4 multiplied with the number of data, which is 8. Okay, 8 divided by 4 into 2 times 3 equal to 6. Okay. For this one here, we assume that it isn't because the number of data is all even number. Okay, so we look into the 6th observation plus 7th observation divided by 2. 1, 2, 3, 4, 5, 6, and 7, which is 7.6 plus 8.6 divided by 2 equal to 81. Okay, and 40th percentile, 40/100, multiplied with number of data, which is 8 here, equal to 3.2, round up to x equal to 4. Okay, which is not integer here, so P40 equal to 1, 2, 3, 4. Okay, fourth observation here, 1, 2, 3, 4 equal to 5.4. So the following table shows the marks obtained by 30 students in maths quiz, where the maximum marks is 10. So find the mean, mode, median, first and third quartiles, interquartile range, and 60th percentile. Okay, are you all ready? Okay, let's move, continue. Okay, before that, because we are in the next page slide of this. Okay, so please look at this table. Okay, the marks and also the number of students, meaning there are 2 students getting 2 marks, 4 of them getting 3 marks. So if I write all this in a raw data, ungrouped data, and come up with 2 and 2, because 2 students getting 2 marks. Then 4 students getting 3 marks, 3, 3, 3, and 3. 3 of the students getting 4 marks, 4, 4, 4. 6 of them getting 5, 5, 5, 5, 5, 5. Okay, there's no space, not much space for me to write down list down all here, unless if I rewrite on the top of this question here. It's okay, never mind. So then, from the data, mean or x bar equal to the summation of fx. No, not the function of fx. Okay, sorry. Okay, f times x divided by summation of f. Okay, so from there you can see this 2 students getting 2 marks plus 4 students getting 3 marks, and then 3 students getting 4 marks, and so on. Continuing, 5 times 6 plus 6 times 4 plus with 7 times 5 plus with 8 times 4 plus 9 times 1 plus 10 times 1. And all of this divided by the numbers of students, which is 30 of them. Okay, use your calculator, divide by 30, and you'll get here the average is 5.6. And the most appearance number, the most marks number of students getting the appearance most, which is 5. Okay, so then this is the marks, and the marks that appear most means that the number of students is getting the number of students, most students getting the one we call marks, which is 5. 5 appears 6 times, the rest which is less than 6. So then okay, so it is mode equal to 5. Then next, mean, mode, and median. Median, half from the data here multiplied with 30 equal to 15. Okay, this is median. Okay, half times 30 equal to 15 means that here we look at that's 15 observation. X15 plus X16 divided by 2 equal to, okay, the median here is 5 plus 6 divided by 2 equal to 5.6. Okay, how we know that it's 15 observation equal to 5 and 16 observation equal to 2 equal to 6. Okay, so from the data again, if I rewrite all here, the number of students getting 2 marks, 2 of them, 2 and 2, and then getting 3 marks, 4, and getting, wait, okay, sorry again. Okay, students getting 3 marks, 4 of them. And getting 4 marks 3 times, 4 to 3 students. Getting 5 marks 6 times. 1, 2, 3, 4, 5, 6. Okay, and then 6 mark 4 of them. 6, 1, 2, 3, 4. Getting 7, 5 of them. 1, 2, 3, 4, 5. Getting 8, 4 of them. 1, 2, 3, 4, 9, 1, 10, 1 of them. Okay, so there are 30 of the students according to the questions. So look like okay, for X 15 and 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we count again. First observation, second, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, this is a 15 observation, and 16 observation equal to 6. So 5 plus 6 divide by 2, then you get 5.6. Okay, and then according to the question, first and third quartiles. First quartile, 1 over 4 times 30 equal to 7.5. Okay, so we round up to X 8 observation, 5 to 8 observation equal to, okay, 1, 2, 3, 4, 5, 6, 7, 8 equal to 4. The first quartile equal to 4. Okay. And the third quartile, 3 over 4 times 30 equal to, okay, so find out here the answers for yourself. We give you 22.5. So we round it up here. It gives us the 23rd observation. So 23rd observation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So then, the third quartile equal to 7. So, in the quartile range, which is equal to Q3 minus Q1, 7 minus 4 equal to 3. Okay, and the last final in the question then, the 60th percentile. Okay, so I give a space, make a space on here, 60th percentile, which is 60 over 100 times 30 equal to 18. So we take the 18 observation, okay, X 18 observation plus 19 divided by 2, which is 16, 17, 18. 18 and 19. 6 plus 6 divided by 2 equal to 6. Okay, that's it. The solution for the example in the lecture notes then. Okay, so conclusion means that we almost recall at the end of the data of the notes here. Okay, so please refer to the recall from the beginning of the recall, the whole content of the notes, and try to understand my explanation here. So these all the summaries of all the things that we discussed just now and the examples that I showed to all of you. So that's all for today. Thank you very much, and till we meet again. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.